All right, let's scoot on. We're talking about sets and compound inequalities in this particular lecture. So before we get too much into that, there's two vocabulary words that I need to make certain you understand. They're conjunctions, and we use them in the English language all the time. Red and blue, red or blue, they mean two different things, don't they? So we use those conjunctions in math also, because math also has compound sentences. But they're not always called compound sentences. They could be called compound inequalities or compound equations. So just so you know. Okay, so let's talk about the two words that I'd like to speak about. The first word is and. If the ball is red and blue, that means it's both colors at the same time, isn't it? Okay, so in math, the word and represents the word intersection. Like streets. Some streets intersect each other, don't they? They have a common meeting point. Agreed? Okay. The symbol for intersection is this upside down U. The other word that is used, the other conjunction that is used, is the word or. The ball is red or blue. It's either red or it's blue. It's only one color. Well, the word or in math means union. And I describe union as kind of a greedy little thing. In math, if the word or is used, then it means union, which means it wants to include everything that's in those two sets I may be talking about. And the symbol for union is this right side up U. Got it? Okay, so we're going to be talking about, I'm going to give you an example. I'm going to give you 4 different sets, and we're going to be talking about the intersection as well as the union for those 4 sets. So hang in there. I'll be right back. Okay, as promised, here are the 4 sets that I was speaking about. Set A is the set of x such that x is an even integer. Set B is the set of x such that x is an odd integer. C is the set of the numbers 2, 3, 4, and 5. And D is the set of numbers 4, 5, 6, and 7. Got it? Okay, so let's look at problem number 1. Problem number 1 is saying C, and what's that upside down U mean? Intersection. C and D, they want the intersection between sets C and D. So remember, just like 2 streets intersect, they have something in common, right? When at their intersection, like they have a section in common, right? So I'm looking at sets C and D, and I'm trying to figure out what do they have in common. So that's an easy way to think of the word intersection. What do they have in common? Well, I'm looking, and I'm seeing they have 2 numbers in common. What are the 2 numbers? 4 and 5. So, here's how you write that. It is the set, because we're talking about sets, of the numbers 4 and 5. Got it? Cool. Let's look at number 2. Again, we're looking at sets C and D, but now they want the union. Remember what I said about union? Union is kind of greedy. It wants it all. So in other words, they want everything in both sets. So for C and D, the union be set between sets C and D, I'm going to give them everything in both sets. So 2, 3, 4, 5, right? Because that's out of C. D starts with 4 and 5. Well, I already have them written, so I don't need to write them again. And then I include 6 and 7. Got it? Good. Now, let's look at number 3. Number 3 is looking at the sets A and C. A is a set of even integers, and C has these 4 numbers in it. And they want the intersection between these 2 sets. So let's see about that. If A is only talking about even integers, and C has the numbers 2, 3, 4, and 5, then their intersection are just what numbers? Good. 2 and 4. C or A only has even numbers. C, the only even numbers in it are 2 and 4. Cool? Let's look at this next one, number 4. It says B union C. So it wants B, which is the set of odd integers, and C, which has the numbers 2, 3, 4, and 5. So union means it wants both of these sets together. Well, that's kind of interesting because I'm going to have all the odd integers, and I also need to include the 2 and the 4 because those aren't odd integers, but union said it wants them all. So here's the deal. Here's a way to write this. It is the set of x such that x is an odd integer. Now remember, union is the word or x equals 2 and x equals 4. That's how you would write the solution for number 4. It's kind of an interesting way of writing it, but there's no other way to write it. Got it? And hopefully you caught my spelling error because I sure did. Integer. Got it. Good? Let's look at number 5. Number 5 wants the union between A and B. Well, A is the set of all even integers, B is the set of all odd integers, which means technically A union B is just the set of integers, isn't it? Odd and even together. Agreed? So there's a couple different ways you can write it. I can say the set of x such that x is an integer. And then I could also say, so this is one way of writing your answer. A second way of writing your answer is the set of -2, -1, 0, 1, 2, etc. Okay? So pay attention to what the authors of the book want. Do they want option 1, x is an integer? Or do they want option 2, where you kind of need to list out the integers? Got it? Okay. And then number 6. Number 6 wants the intersection between sets A and B, don't they? Well, if one set has even integers and the other set has odd integers, is there anything they have in common? Yeah, they don't have anything in common because even numbers and odd numbers never cross over, shall I say, right? Okay, so I have nothing to put in this set of numbers, do I? Nothing, because there's nothing in common. So here's the deal. It is called the empty set. And literally, it's the two braces with nothing in between them. That is known as the empty set. Cool? Okay, so hang in there, and I'm going to show you how and the word or, these conjunctions, I'm going to show you how they apply to solving inequalities. I'll be right back.